Graphing logarithmic and exponential functions in Algebra 2. So logs and exponentials are somewhat new. Logs should be brand new to you, and they are functions with the word log in it. And then we have exponential functions, which we have seen before because they are functions with an exponent. Today we're just going to talk about graphing them. So first, if I look at my log function, y equals log of x plus 2 minus 3. We still have vertical and horizontal asymptotes with each of these. For these, though, log functions, they never have a horizontal asymptote. So you can just write none for that. And that is the case every single time. They never have a horizontal asymptote. They do have a vertical asymptote. And to find that, you just take whatever is inside the parentheses. In this case, it is x plus 2, and set it equal to 0. Then you solve, and you get x to equal negative 2. So my vertical asymptote is x equals negative 2. And yes, you need the x equals there. Then I come over here. I'm just going to change the color. So at x equals negative 2, I then have my vertical line. All right. Now, to graph this, I go to my calculator. So I'm going to turn that on. I'm going to hit the y equals button. Log, the log button is actually right next to the number 7. So we're going to say log, and then x plus 2 minus 3. So your y equals should look like mine, and then you can hit graph. Logs are tricky with the calculator because it looks like it stops. That's not the case. So when you graph it on your paper, and I'm going to show you in this example, but you'll need to continue the graph all the way down. Remembering it does not cross the vertical asymptote. So I'm going to plot my points. I'm going to go second, graph, and I want to plot points that are easy, not decimals. So it looks like I can plot negative 1, negative 3. I'm going to use a different color. So negative 1, negative 3. And it looks like that's going to be, well, I can also do 8, negative 2, but my graph doesn't go up to 8. So I know, and if I hit graph on my calculator, the graph looks something like this. Remember, I said you want a curve. Oh, we don't want it to hit the asymptote, but you do want a curve so it's going down. You need arrows on both ends, especially if you want to get these correct, but you definitely need arrows on both ends. Okay, we're going to go through the same process with the exponential functions. Exponential functions, they never have a vertical asymptote, so you get to write none on the VA. Horizontal asymptote, they do have, and in order to get that, it's whatever is at the end. And there are no special rules on this one, so we just get y equals negative 2. So again, I'm going to go over to my lines, and I'm going to graph it at y equals negative 2. Then I'm going to go to my calculator, and I'm going to go to y equals, and now I'm typing in my exponential, which is 3 to the x plus 4, and then minus 2. Make sure that minus 2 is not up with the exponent, that it comes after it. We can hit graph to see what it's going to look like, and then we can plot our points. So second graph. And again, we want to plot the points that we can. So I can do -4, -1, -3, +1, -2, +7. And again, you can hit graph and see which direction it goes, which we're going to then curve up. Hopefully yours looks a little bit better than mine. It should hit through all of the points. And again, arrows on both ends. So that's a big overview of the log and exponent graphs. I'm going to do 2 examples of each. There are plenty more examples on this note packet, but I'm just going to do the first 2. So number 1 is an example of an exponential, and just like we learned up above, exponentials never have a vertical asymptote. So at the VA, I can write none. To find the HA, it's whatever's at the end. So we need y equals 4. And you need the letter. If you don't have y equals, you will be wrong. Then we're going to go over here. Y equals +4. I'm going to draw my dashed line. Then to graph it, go to my calculator. I'm going to type in parentheses 1/2 to the x power, and then +4. Can hit graph to see what it's going to look like. And then second graph is how I plot my points. So we have 0, 5, -1, 6, -2, 8, but my graph doesn't go up to 8. So my graph is going to look something like this. And again, I can hit the graph button to double check. Now, x-intercepts. X-intercepts are where y equals 0, and it's where we cross the x-axis. For this problem, we are not going to have any x-intercepts because the asymptote prevents us from getting to the x-axis. So we're going to say none. Y-intercepts are where x equals 0, and we hit second graph on our calculator to find that every time. So second graph. When x is 0, y is 5. So parentheses 0, comma, 5. Domain and range, that's also a review. My domain goes left and right. So this graph is going to continue going to the left, and it's going to continue going to the right without any restrictions. So we say -infinity to +infinity. The range is up and down. So this is going to go all the way down until the number 4, because that's where the asymptote is. So we're going to do parentheses 4, because you can't touch the asymptote. Comma, how far up does it go? Well, it goes all the way up to infinity. Then the end behavior of the graph, so as x approaches -infinity. So as I move down the negative values of x, my graph is going to continue to go up, which is +infinity. As x approaches +infinity, so the positive x values, my graph is going to continue to go towards the asymptote, which is at the number 4. So I'm going to do number 2. Again, it's another exponential, which means my vertical asymptote, so my VA, is always going to be none. And my HA is whatever comes at the end, in this case -5. So y equals -5. Then again, I'm going to go and plot -5. It must be a dashed line. Y equals -5. I can then go to y equals, type it in, so 4 to the x minus 1. Then we have -5 at the end. Hit graph, see what it looks like. Second graph to get me my points. Now here we do have a -5, -5. So there is an actual point that is on our asymptote. Sometimes that happens, but for the sake of this class, we're going to pretend that it doesn't happen. This starts to get into the more pre-calc calculus stuff that we won't touch. So we're going to pretend that's not there. And I'm going to plot 1, -4, and 2, -1, and it looks like that's all I can plot. So then I'm going to graph. Hopefully yours looks better than mine. Then we can figure out the rest. So x-intercept. Does this actually cross the x-axis? Yes, it does. Somewhere in here. Remember, to find that, we go to our calculator. So we hit graph, and we go second, trace, option 2. You want to move the spider blinker as close as you can to the x-intercept. Left bound, we go left 2, enter. Right bound, we go right 4, enter. Guess, enter. So in this case, my x-intercept is at 2.16, 0. You must write it as a point. Remember, the y-intercept, we always get that from our table. So second graph, when x is 0, y was -4.75. 0, -4.75. Domain is left and right. So this is going to keep going to the left, and it's going to keep going to the right. So we have -infinity to +infinity. Range is up and down. So how far down is this graph going? The lowest it can go is -5, because that's where my asymptote is. So -5, comma, it's going to keep going up forever, which is infinity. And lastly, we have our end behavior as x approaches -infinity. So as I go down my negative x values, my graph is going to continue to get closer and closer to my asymptote, which is at -5. As x approaches +infinity, so as I look at the positive numbers, my graph is going to continue to go up, which is +infinity. So those are two examples of exponential graphs, and if you flip the page, you can see that you have two more examples. We are actually going to skip those for this video, and I'm going to give you two examples of logs. So I will be doing problems 5 and problem 6. Okay, problem number 5 is a log function. And with a log function, we are going to have a vertical asymptote, but we are never going to have a horizontal asymptote. So we can say none for that one. Remember, my vertical asymptote comes from whatever is inside the parentheses. So in this case, x plus 1, and we set that equal to 0. Then we just have to solve for x. So in this case, x equals -1. Remember to write the letter with it. X equals -1. So now when I go to my lines, at x equals -1 is going to be my dotted line. Then I can go to my calculator and I can say log So y equals, remember, the log button is next to the number 7. So log of x plus 1, close your parentheses, hit graph. The log functions are tricky because it looks like it stops. Remember, when you graph it, you need to continue the function. So we hit second graph to get our points. So I have 0, 0. And anything else? Doesn't look, well, I have 9, 1, but again, my graph doesn't go to 9. So we curve it this way, and we curve it along the asymptote. So my x-intercepts are still where y equals 0 and where it touches the x-axis. It touches the x-axis at 0, 0. My y-intercept, I look in my table, and I'm looking for where x is 0, y is 0. And it's okay that sometimes the x-intercept and the y-intercept are the same. Remember, domain goes left and right, so how far left does this graph go? Well, it can only go to -1 because that's where my asymptote is. So my domain is from -1, comma, it's going to keep going to positive infinity to the right. Range, how far down can this graph go? Well, the arrow means it can keep going down forever. So we're going to say from -infinity, comma, all the way up to positive infinity. And then lastly, the end behavior. So this part's a little bit different. This is saying x is approaching some number when f of x approaches -infinity. So as my graph is pointing down, it's getting closer and closer to my asymptote, which is at -1. So the asymptote always goes in the end behavior slot. And then as x approaches positive infinity, my graph will continue to go up to positive infinity. So you can pause the video and try number 6 if you want. If not, I am going to go through it. So first I'm going to do my asymptotes. So my vertical asymptote, I do have one, and again we're just setting the parentheses equal to 0. So x plus 3 equals 0, we get x to equal -3. Then I can go and graph that at x equals -3. Oops. My horizontal asymptote is none because it is a log function. Then I can go to y equals. I'm going to type in the log of x plus 3, close the parentheses, plus 1. Hit graph to get a look. Second graph to get my points. So I have a -2, 1. Now let's see if we have anything else. 7, 2, which I can graph. So we're going to curve this way and curve down along the asymptote. Make sure it does not touch. I know mine does, but make sure yours does not touch the asymptote. Now, x-intercept, does it touch the x-axis? Yes. So we are going to go second, trace, option 2. Get as close as you can to your x-intercept, and then left bound we go left twice, enter. Right bound we go right 4 times, enter, guess, enter. So my x-intercept is at -2.9, 0. Remember, my y-intercept I get from my table, so second graph, when x is 0, we are going to round this and we're going to say 1.48. So x is 0, y is 1.48. Domain, the farthest left I can go is -3, comma, the farthest right I can go is infinity. Range, the farthest down I can go is -infinity. Farthest up I can go is positive infinity. Then we have our end behavior. So again, x is approaching some number as my graph approaches -infinity. So as my graph approaches -infinity, it's also going towards -3. Again, the asymptote and your end behavior should match. Then as x approaches positive infinity, my graph is also approaching positive infinity. So those are two examples of log graphs. Again, if you go to the next page, you have two more examples. We also did complete the bottom part, numbers 9 through 18, but you should be able to do that now. And you can always check in with me on the answers to those in class or at any Bulldog block.